Hey there, class. Today we're going to be making a lava lamp, and of course, we're a chemistry channel primarily. So we will be talking about some chemistry concepts and why this do-it-yourself project is just so cool, and everyone can do this. And we'll explain a little bit of kind of the chemistry behind why this kind of cool at-home project kind of works. So, very easy setup. We're going to take a container. This has already been cleaned, and we're going to add a little bit of water to it here. Pretty good. Now, we're also going to add a bit of vegetable oil here. And this is, we're just going to go ahead and kind of complete the project first, and we're going to talk a little bit about kind of why all these things kind of work together. So we'll just complete the project, then we'll kind of go back and explain. And you can kind of see, we got some layers kind of forming here. Awesome. Now, there's going to be one more touch. We're going to add some food coloring. And we don't need a whole lot. Let's add a couple drops. We're starting to kind of see that kind of come through here. And there's going to be one last part. We're going to take an Alka-Seltzer tablet. And actually, we're going to break these up just a little bit. Okay. Then we're going to add it to our jar. Okay, and then we're starting to see the reaction take place. We're starting to get our lava lamp. Now, as always, what's the chemistry here? Excellent question. So, we've got a few different principles kind of happening here. The first being density. Now, as we've all learned, density is mass over volume. And so the density of the water and the oil are much different. And we're going to talk a little bit about kind of why that is. We're going to look at the structure, actually, of oil. And I think once you get a visualization of kind of what an oil molecule looks like, it's going to be easier to understand why the density is the way that it is, because at first glance, you may not realize it. So, we're going to take a quick peek here at oil, the structure of oil. This is a little bit of organic chemistry. Now, as you all know, the structure of water is a simple 2 hydrogen atoms and 1 oxygen. This is a chain of an oil, a vegetable oil specifically. And so you're thinking to yourself, holy smokes, we've got a whole bunch of carbons there, we've got some oxygen, we've got all these hydrogens. You'd think, oh my gosh, the weight has to be so much different, or the density, I should say, the density is much different. But what we're looking at, again, is mass over volume. We've got these long chains here So the long chains kind of make up for all of the attached molecules. Secondly, there is a difference in polarity, and this is specifically why water and oil do not mix. As we learned earlier this week, a water molecule is made up of basically two ions. You've got a non-metal with oxygen wanting to get two more electrons, and so here comes two hydrogen atoms wanting to donate two electrons, one from each. But an oil, as you kind of saw, doesn't want to give up anything. All of the carbons and oxygens and everything else are fully packed, if you will, with hydrogens. There's, as you saw earlier, there's hydrogens up and down the chains. So the way this kind of works is that, you have small charges, if you will, within the water, but the oil has no charges whatsoever. It is zero charge. So this is literally why water and oil do not mix, is because there is zero attraction between them. And then lastly, we added the Alka-Seltzer tablet to this, and the Alka-Seltzer, when reacting with water, created a bit of CO2. This is what we saw earlier. And as some of you may know, Alka-Seltzer is a simple over-the-counter treatment for really anyone who has issues with stomach acid, a bit of nausea, because there is some sodium bicarbonate within the Alka-Seltzer, so it helps to interact with a person's stomach acid to hopefully bring some relief and decrease it a bit. And so when we had the Alka-Seltzer traveling all the way through the oil to the water, creating the bit of CO2, then what we saw was the CO2 lifting the food coloring that we saw to the top, creating the lava lamp. Stay tuned next week for more chemistry lessons and presentations.